In this rational function of f of x, the degree of the numerator is exactly 1 higher than the degree of the denominator. So we can start thinking about the behavior of a slant asymptote. And when I graph this function, I can see that happening. I can see that my function follows a diagonal line as it goes to positive infinity and as it goes to negative infinity. Now let's try to find the equation of this slant asymptote. So let's look at this rational function and perform long division. The denominator goes on the outside and the numerator goes on the inside. When I identify the first term on the outside and the first term on the inside, I want them to match them up using multiplication. So ask yourself, x squared, what can you multiply so that it matches 3x to the third? Well, that will be the expression of 3x. So now let's perform that multiplication. X squared times 3x, so that will be 3x to the third. Multiply the next term. Negative 3x times 3x, that will be negative 9x squared. Multiply the last term. 2 times 3x, so that's just 6x. But before we combine, let's switch the sign. So that becomes negative, that's a positive, and that's a negative. Now let's combine. 3x to the third, it is going to cancel out. And now let's combine the terms with the x squared. X squared plus 9x squared. So that's going to give me 10x to the second. So now let's combine those with the variable of x. That's going to give me negative 14x. And this value of negative 4, let's just bring that down. So let's repeat the process. First term on the outside, first term on the inside. Let's match them up using multiplication. So x squared, what do we need to multiply to obtain 10x to the second? Well, that's just the value of 10. So let's write that down. Now let's perform the multiplication. X squared times 10, that's 10x squared. Move to the next term, negative 3x times 10, well, that's negative 30x. Well, last multiplication, 2 times 10, well, that's just 20. So before we combine, we switch the sign. So that becomes negative, that becomes positive, and that becomes negative. Now let's combine. The x squares are going to cancel out. When I combine the x's, that's going to give me 16x. And when I combine the constants, that's going to give me negative 24. So we are done. Because x squared, there is no expression with a positive exponent that will give me 16x. So we have reached our remainder. So the initial rational function of f of x, now we can write that down as 3x plus 10 plus the remainder, 16x 24, divided by x squared minus 3x plus 2. So let's erase this division to give myself some space. So we have shown in the previous example that this expression goes to 0 as we consider the behavior towards positive infinity. And this expression that is left of 3x plus 10, this is going to be the function for our slant asymptote. This diagonal line that the function is going to follow is going to have an equation of y equals 3x plus 10. Which again, this is something that we define as slant asymptote. And just to recap, this only occurs when the degree of the numerator is exactly 1 degree higher than the degree of the denominator. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.